So most of you are aware about this oil removal. It's a fairly new process, at least the current one that ethanol plants are using. There are previous data on removing fat from distillers, but frankly, all of that previous data is a different process than what's currently being employed. And as it turns out, I believe that's important, but I'll let you judge that when we get all done. So we're going to talk a little bit about that, and then Melissa will discuss her data on growing calves and finishing cattle, and then have some conclusions. So we have some folks from the ethanol plants here. Dwayne Christensen, I think I saw Chuck Woodside earlier, and others. And so they can answer some of this process questions better than I can. Try not to mess that up. So most of you have seen this process where grains go to the ethanol plant, and that grain is ground. In most of the plants add moisture or wet that grain and heat to cook it. Then they'll add enzymes to help with the starch conversion to sugar. Then they'll add yeast. That yeast is then what's responsible for converting in fermentation the sugar to alcohol and CO2. So that process is pretty straightforward, but what comes through is called the whole stillage, and then that's centrifuged into distiller solubles and distillers grains, both of them wet, and many times then those are put back together to make wet distillers grains plus solubles. They can be partially dried to make modified distillers grains plus solubles, or completely dry, or mostly dried to 10% moisture to make dry distillers grains plus solubles. Now that's the schematic I've been using. Mark Corrigan, who was a PhD student, he did a much nicer job with animation, so I've stolen his animated slide. So starch to ethanol, and corn goes to, the starch goes to ethanol, and then you got this whole stillage. But what's unique here, and I think it relates to this process, is they normally centrifuge that whole, see, I couldn't make that process. They normally centrifuge that whole stillage to make what's called thin stillage and wet distillers grains. So all plants make that. And then that thin stillage, the wet distillers grains can be just marketed as wet distillers grains. The thin stillage is evaporated to what's called solubles. So it goes from, I believe, 5 or 6% solids to 30 or so during that evaporation process. And this is the process where they're targeting oil removal. And so what they're in essence doing is centrifuging. I was in a plant on Monday and I was surprised. I thought they were just centrifuging the thin stillage. In that specific plant, it was actually partially evaporated solubles. So they were actually drying it and then spinning it. But this is where there's oil. There's oil in both of these streams, but this is the oil that's being spun to remove the oil, at least part of it, from the distillers grains. So that's the only reason why the process is important, in my opinion, is that this is the stream they're targeting. Again, those are put back together to make wet, modified, or dry distillers grains plus solubles. Our estimate, and I hung on this, is that in 2012, about half of the plants are doing this. I think US-wide, I heard 95 out of the 200 or so are currently employing this oil removal process from these dry mill ethanol plants. So the distillers grains are going to be lower in fat because of that. So again, the soluble stream's the part that's removing, and I put in here, quote unquote, the free oil. That has nothing to do with price. That has to do with that it's not the oil that's bound up still in parts of that kernel or part of that germ. It is in fact probably mostly the free oil that's been separated from the feed. Here's the issue, in my opinion, is they're receiving about 30 to 40 cents per pound for oil. And of course, distillers grains right now, which is historically fairly expensive right now, is 12.5 cents or so, 11 to 12.5 cents. So I think that's the issue why they're trying to explore this. And I've heard, that obviously it's millions to put in these centrifuge systems and get that to work, but a fairly quick payoff for that capital expense. In general, I think most of you are aware, the distillers grains are going to run normally 12 to 13% fat. With this process, that's likely going to be in the future 8 to 9, at least from those plants that are removing it. About a third, our estimates are about a third of the fat that's in distillers grains is in this soluble stream to begin with, and about 2/3 in the grain. If that is true, and they remove all the oil out of the solubles, that means distillers grains would go from 12 to 8% because that's still got 2/3 of the oil in the grains, if that's true. Okay, so we saw this on the horizon. You can come up. And so we wanted to explore this issue, but frankly, we needed to have the distillers grains that has the oil removed. So we needed it from plants that would do that. And so we worked with Green Plains and funding from the Nebraska Corn Board to do a couple trials on this over the last winter, spring months. And so Melissa will share her information with you. Oh, I'm sorry, I was going to present one more thing. See, now she said she was nervous. Now I'm nervous. I want to talk to you about this thing. One issue that we looked at is whether if you remove the solubles from the grains, what's the impact? So before she presents, I wanted to present this data where we've looked at some impact of not having solubles. Now that's not having the fat from solubles. That's not having any solubles at all. So Karina Gotzi did this data. This was a few years ago. It's in the 2009 beef report. Fairly typical study for us and good replication. I think it's important to point out here that the distillers grains that didn't have solubles on it and the distillers solubles that came in were not from the same plant. And that may or may not be an issue, but we could not get that coordinated. But the distillers grains we fed had no solubles, and then we brought in solubles separate, and so we could put on the right amount of solubles that we want at the time of feeding in the feed truck. So what we looked at was a corn-based diet with no distillers grains, 82.5% corn. Alfalfa hay was the rough feed source and supplement. There was some molasses in this diet to help hold it together. Then we had 20% inclusion of distillers grains and 40% inclusion of distillers grains. And distillers grains had either all of that, 20% as the grains, or an 85-15 ratio, so that's 17% grains, 3% solubles, or 70% grains, 30% solubles, so the total was 14 grains and 6% solubles. So you notice all of them add up to 20% total distillers grains. It's just that the ratio of distillers grains to solubles varies. And then the same concept at 40% inclusion. So we were curious what happens if you don't get the solubles back. And I wanted to present this because it might relate to what happens if you remove the oil from the solubles. The fact we observed, I would look at this one here, the solvent extraction, not the ether extract. That was some work that we've been doing that I think is more accurate for the solubles. But the fat in the control was 3.1. As we added 20% distillers, the fat went from 4.6 to 4.9. And as we went from the 40% inclusion, the fat went from 5.9 to 6.7. That's in the total diet. Now, our fat in the solubles was about 16%, and in the grains it was 10%. Those might be numbers to keep in mind. So this slide's not critical, except there was no interaction between level in the diet and fat inclusion, and solubles ratio, so I'm just going to discuss inclusion level and then also the impact of the solubles. So as we added distillers grains, in general, didn't matter whether the solubles were added back or not, as we increased inclusion, gain increased linearly. Feed conversion got better linearly, so that's not shocking. As we added distillers grains, we've seen better gains and better conversions. That's been about 27 or 8 times that we've observed that over the last 15, 20 years. But what was intriguing to us is that when we looked at whether we had the solubles on or not, there was no impact on dry matter intake. There was no impact on average daily gain. I would point out this one looks a little bit lower, but statistically there was no impact. And no impact on feed conversion. So we were a little surprised when we did this study that adding the solubles back on didn't seem to have as big impact as what we expected. But now the question is what happens if you have the solubles back on but not the fat in there? Same thing about the carcass characteristics, really no impact. Okay, now I think I'm ready for Melissa, sorry.
You steal my clicker?
Yes.
Can everybody hear me? Okay. Good morning, everyone. My name is Melissa Jolly, and as Galen has mentioned, I am a master's student working under him and Terry Klopfenstein. The work we have been working on, as you all know, is the corn oil extraction in distillers grains and condensed distiller solubles. The first study that I'm going to discuss with you this morning is dealing with feeding these condensed distiller solubles to growing calves. Oops. So the objective of this study was to evaluate with and without fat removal in condensed distiller solubles in forage diets on growing performance. It was an 84-day growing study utilizing 60 crossbred steers. They were individually fed using the Kaling gate system, which there's a picture over here on your right-hand side that demonstrates the system. And based on the initial body weight, steers were stratified and randomly assigned to treatments. The treatments consisted of, first, a 2x2 plus 1 factorial arrangement comparing level of solubles by fat, with fat being the de-oiled and normal fat at the 6.3% level and the 20.1% fat in those solubles. The level being at 0, which was the control, 20 and 40%. We also wanted to analyze the separate 2x2 factorial looking at comparing forage by fat, the fat again being the de-oiled and normal fat, and forage looking at a grass diet, which was an 80-20 blend of sorghum, brome hay and sorghum silage, and also comparing that to wheat straw. The 40% is looking at the solubles inclusion in these diets. And here are the diets. As you can see, again, we had an 80-20 blend of brome hay and sorghum silage. And when we increase the solubles, we see that this replaces a portion of this grass diet. And again, we also had looked at a wheat straw diet at 55% wheat straw and 40% solubles. Looking at the ingredient nutrient analysis of these solubles, we can see that the fat content, again, of the de-oiled was 6.3%. Normal fat was 20.1. Looking at the crude protein in de-oiled solubles was 20.8. And then the normal fat solubles was 26.4. So the increase in crude protein suggests that when we remove the fat from the solubles, that crude protein does increase. And sulfur was 0.99 in the de-oiled solubles and 0.83 in the normal fat solubles. And looking at the dry matter content of these solubles, the de-oiled was at 27% and normal fat was at 27.5%. Now looking at the dietary nutrient analysis, we wanted to look at the total fat in all the diets. The control was at 1.47% dietary fat, and obviously when we increase solubles from 20 to 40, it's going to increase the fat content. So first looking at the de-oiled, we see that 20% was at 2.39, 40% was 5.15, and then again with the normal fat increase at 20% from 3.23 to 40% at 8.83. And looking at the wheat straw, at 40% inclusion of solubles was 2.91, and normal fat wheat straw was at 8.42 total dietary fat in the diet. So looking at the results for level by fat, just want to point out that there was no interaction between level by fat for these results. And for the effect of fat content, ending body weight, dry matter intake, and average daily gain, the fat content was not significant, meaning that the de-oiled was not statistically different than the normal fat solubles. But for feed to gain, there was a tendency for it to be significant at 0.07. So looking at the feed to gain, we could see here at the 20% level for the de-oiled, the feed to gain was 7.58. And when we compare that to the normal fat at 20% was 6.67. So they did have improved feed conversions for the normal fat. So that's where that difference is coming up. But when you look at the 40%, de-oiled was 5.71. And for the normal fat at 40% was 5.65. So they're pretty similar at the 40% level. So looking at this graphically, we can see that the low fat or de-oiled is represented in the blue line, and the high fat or normal fat is represented in the red line, with solubles level on the horizontal axis and feed to gain on the vertical axis. And we can see, here at the 20% level that the high fat or normal fat steers fed these solubles did have improved feed conversions over the low fat, but at 40% they are virtually the same. So looking at the forage by fat, first I want to point out the forage by fat interaction column here, and as we can see there's a tendency for dry matter intake to be significant at the 0.06 level. And also looking at the effect of fat, again we see that there's no significant difference between de-oiled and normal fat solubles. And looking at the forage at the far right, we can see that for ending body weight, dry matter intake, average daily gain, and feed to gain, comparing the grass diet by the wheat straw, they were significantly different. So looking back at the dry matter intake for the interaction, we see that the grass silage treatment, they did have higher intakes, but they were statistically the same between de-oiled and normal. But when you look at combining in the wheat straw, they were statistically lower than the grass silage treatment steers. So moving on to the finishing study, looking at oil extraction and modified distillers grains and solubles on feedlot performance. So the objective of this study was again to evaluate the modified insolubles with and without corn oil removal on feedlot performance and carcass characteristics. We utilized 225 calf-fed steers with 25 pens and 9 head per pen. They were blocked by body weight and assigned randomly to treatment. They were implanted with Revlar IS on day 1 and Revlar S on day 83, and they were on feed for 179 days. All modified distillers grains plus solubles arrived to the feedlot prior to the start of the experiment. They were all from the same plant, and all solubles were from the same plant, but they arrived about every 3 weeks when needed. And samples were taken from all byproducts directly off the truck and analyzed for fat and crude protein and sulfur, as well as weekly samples were taken to analyze this as well. So looking at the treatments, we see that we did a 2x2 plus 1 factorial arrangement with looking at the fat content, again being de-oiled and normal, and the inclusions at 27% solubles and 40% modified. Previous research has shown that these are the optimum levels to feed these byproducts at for optimum average daily gain and optimum feed to gain. So looking at the diets, we can see we had a 50-50 blend of high moisture corn to dry rolled corn, and when we included the solubles at 27% and the modified at 40%, they replaced a portion of this corn. We used sorghum silage as the roughage source, and we had a 5% supplement added to these diets. Again, looking at the ingredient nutrient analysis of these solubles and modified, the de-oiled was running at 6% with the normal fat running at 21.1. Looking at, just going straight down the columns, looking at the crude protein, again there was an increase at 29.6% for the de-oiled solubles compared to the normal at 27%. Sulfur, 1.26% in the de-oiled solubles and 0.78 in the normal fat solubles. And again, dry matter was at 27 to 27.5%. And looking at the modified, we see that the de-oiled fat was 9.2 and the normal fat was 11.8. And again, slight increase in crude protein at 33.7 for the de-oiled modified compared to the 33% for the normal fat modified. And looking at sulfur content, again, slight increase at 0.65 for the de-oiled modified and 0.56 for the normal fat modified. Even though these are pretty high levels of sulfur, we did not observe any signs of polio in these steers. And looking at the dry matter for the modified, it was running between 46% and 46.5% between de-oiled and normal. So looking at the dietary fat in all the treatments, the control was running at 4.43 total dietary fat, de-oiled at 4.72, which is pretty similar to the control. The normal was at 8.8%. The de-oiled modified was at 6.12, and the normal fat modified was at 7.19. Now looking at the results for this performance study, first I want to direct everybody's attention over to the CDS and modified columns over here on the right. Again, this is comparing the de-oiled solubles versus the normal, and the de-oiled modified versus the normal modified. And as you can see, there are no significant difference, again, between the two. However, when we add in the controls and compare the controls to these diets, there is a significant difference between final body weight, dry matter intake, average daily gain, and feed to gain. So first I want to look at final body weight. As we can see for the controls, they were statistically had lower final body weights compared to de-oiled solubles, de-oiled modified, and normal modified steers. However, they were statistically same as the normal fat soluble steers. And looking at dry matter intake, we see that the de-oiled solubles and normal soluble steers had statistically lower dry matter intakes than compared to the controls, the de-oiled modified, and the normal modified steers, which they were statistically the same, which was interesting. For average daily gain, the controls again had statistically lower average daily gains than the de-oiled solubles, de-oiled modified, and normal fat modified steers. Again, the controls were statistically similar to the normal fat soluble steers. And lastly, looking at feed to gain, we see that the de-oiled solubles, the normal fat solubles, de-oiled modified, and normal fat modified were all statistically similar to one another, and they did have improved feed conversions compared to the control steers. Looking at the carcass characteristics, again, like I mentioned earlier, there was no difference when we compared the de-oiled solubles versus the normal, and when we compared the de-oiled modified versus the normal solubles, modified distillers grains. But again, when we add in the control to compare all these treatments to, there was a significant difference in hot carcass weights, with the control having statistically lower hot carcass weights than the de-oiled solubles, de-oiled modified, and normal modified. But again, the controls were statistically similar to the normal fat condensed distiller solubles. So in conclusion, for growing cattle, if you feed the condensed distiller solubles at 20%, the normal fat solubles tend to have improved feed efficiencies compared to de-oiled, but de-oiled solubles still have improved feed efficiencies compared to controls. If you feed solubles at 40%, both de-oiled and normal fat solubles tend to have similar performance. For conclusion, for the finishing study, cattle-fed solubles or modified, regardless of fat content, had greater final body weights, average daily gain, and hot carcass weights compared to controls. As well, feed conversion, regardless of fat content, was greatly improved for solubles or modified distillers grains compared to controls. So this data suggests that cattle that are fed de-oiled distillers or solubles have comparable performances to normal fat using the centrifugation process of removing oil from solubles.